All right, so one of the companies that we own is called Visual Aim. This is a software business. We developed a asset integrity management system that allows companies such as yourselves to manage the mechanical integrity of many thousands of pieces of equipment. I'm sure you have some sort of system in-house, but for example, Florida Power and Light is one of our clients. I think we're using this on 14 of their plants. This might be something of interest to you guys in the future, but we're basically taking and digitizing and creating digital twins of power plants or petrochemical plants, and then taking in information to assess the condition of equipment, calculate inspection intervals, remaining life, and helping clients to develop maintenance budgets and maintenance scopes of work. So if there's a necessity on your end to take a look at some of our data management solutions, I would be happy to do another presentation with the right guys from our team in the near future. So wanted to kind of introduce this real quickly. From an overall service perspective, TechCorr provides every imaginable non-destructive testing technique that you can imagine. We offer EMATs for furnace tube inspection, automated corrosion mapping for pressure vessels and other sorts of equipment that you would like to evaluate without removing it from service. Guided wave ultrasonic testing is a technique to evaluate long sections of buried piping or insulated piping. Pulsed eddy current is a technique to evaluate or measure metal loss of steel through insulation. So for example, you may have a pressure vessel that is insulated and the cost to remove the insulation and replace the insulation is very expensive. We can use pulsed eddy current to measure the thickness of the steel through the insulation. Other techniques like eddy currents and remote field testing for your exchangers and condensers. Like I said, we have EPRI certified folks on staff that are also ASNT level 3. Phased array ultrasonics, we offer that for either new construction or to evaluate corrosion in piping that may be very aggressive. One of the other techniques that we've become very good at is acoustic emission testing. We're using acoustic emissions on storage tanks, but also utilizing it during the startup and shutdown of reactors and other sorts of large pieces of equipment that might be susceptible to cracking or other thermal issues. So we can attach these sensors to the piping or to the reactor or to the piece of equipment, and as it cools down, we can hear where cracks are occurring within welds or the base material, or maybe at connection points where support is supporting a piece of pipe. We can hear where all that activity is occurring and then address that with other techniques. Obviously, you're familiar with positive material identification. If you're unsure of the material type, we can identify what that material type is without destructively testing it. Short-range guided wave. This is a technique to look at the annular plate of a storage tank from the outside. So we can evaluate the condition of the annular plate without getting into the tank. We could keep going on and on, but techniques like 3D defect profilometry we're using, where we're scanning and extracting hundreds of millions of data points into cloud type environments and able to perform fitness for purpose or failure analysis on pieces of equipment that have failed. So anyways, idea is that we offer a lot of different services and can likely help you as a client or anyone else you know quite successfully. We're probably the most comprehensive tank inspection company out there. We say that with a lot of confidence because we are one of the very few and only companies that does in-service robotic tank inspection. But aside from our in-service robotic tank inspection services, we offer API certified 653 inspectors. We offer acoustic emission testing. We have the ability to scan tanks from the outside. to measure proliflometry, meaning we can strap tanks, we can look at settlement, we can look at bulging on the tanks using 3D proliflometry. We spoke about the short range, automated corrosion mapping, phase array weld inspection, pulse steady current. All these techniques are utilized on above ground storage tanks. And then obviously the MFE floor scanning. So if you remove a tank from service, we'll scan the floor to identify metal loss on the bottom side or top side of the tank. And we also have these drones, these confined space drones, which I'll show you in a bit, that can focus on, that we can insert through a manway on the roof of a tank and fly them within a tank to look at the support beams and underside of the roof of a tank while the tank remains in service, or without having to have confined space entry into the tank. So just different types of floor scanners that we use, Mach 3s, the Silver Wings. We use both of these for tank floor scanning. Some of these systems have automated reporting functionality. The point being is that we have all these techniques for out-of-service tank inspection. Acoustic emissions, we're using this on storage tanks that cannot be removed from service to identify areas within the tank where there might be higher probability of damage, and then we'll focus on those areas with automated corrosion mapping or phase array ultrasonics or some other form of non-destructive testing. This is an example of where we were looking at a tank floor and they were experiencing a leak, but they didn't know where it was, and they didn't want to remove the tank out of service if they could address it some other way. So we attached our acoustic emission system on the tank, and we were able to identify where the leak was occurring, and then able to pinpoint it. So the second they took it out of service, we were able to identify exactly where it was and go ahead and repair that section of the tank. This is very useful when you're building new tanks and hydro testing tanks. Because during the hydro test process, we can identify where there are leaks still within the tank that may have been the result of a crack in a well that wasn't detected using vacuum box testing or other methods. And as they fill it with water, we can identify whether the tank is tight and ready for service. You'll find that some people experience they put a tank in service or fill the tank with water several times before they are able to get rid of all the gremlins, being cracks and other sorts of damage inside these tanks. So this is a great tool to help facilitate the commissioning of a storage tank. All of you have small diameter storage tanks, and so we've developed this very simple ultrasonic system to we basically manually manipulate inside a small storage tank to obtain thickness readings on the floor. The floor itself is basically the only component within a tank that we cannot directly access while it's in service. So this probe allows us to go in through the roof and settle on the floor and take readings throughout the tank to collect the necessary thickness readings to accomplish API 653 minimum requirements for storage tank inspection. And most of the states and the federal government accept this form of tank floor inspection in lieu of removing a tank from service. And as many of you are aware, the costs to remove a tank from service are quite expensive because you have to de-inventory the tank and typically sell that fuel oil at a very high discount. You have to pay for the costs of trucking that fuel wherever you need to send it. You have the cost of cleaning the tank and disposing of the sludge that's in the bottom. And you have to address the VOCs or volatile organic compounds that are released into the air, especially if you're in California. And you then have to inspect the floor and put it back in service. So that whole process could take weeks, and on larger power plants where you have larger storage tanks, it could take months to years to accomplish one single storage tank inspection. And as you know, typically storage tank inspection is only about 1% of the total cost of actually inspecting the tank. The rest is just getting it ready for inspection. So we're able to enter these tanks using a device like this as an example, or our robotic system, and measure the floor condition to calculate if the tank really needs to be removed from service, and hopefully defer the removal of that tank from service to a point in the future. And what that allows you as the operator to do is facilitate other sources of feedstock to remain in compliant with the state or federal laws, or it allows you to build another storage tank that could be used while the original storage tank is being removed from service. The point being, there's lots of economic benefits of using our in-service robotic and manual tank inspection systems. This is an example of the pulse eddy current technique on the side of a storage tank that's insulated. We're measuring the thickness of the shell course itself through the insulation. Our tank wall crawlers that we use to take the thickness readings at 8 cardinal locations surrounding the tank. It also incorporates automated corrosion mapping and phased array corrosion mapping. We have a camera system that we can put through the roof of the tank. Here's an example of our 3-dimensional surveying of tanks to look for shell roundness, strapping, tank settlement, and so forth, verticality. We do lots of drone inspection, as I said, to facilitate 570 inspection and 510 inspections for externals. This is an example of our laser proliferometry. I'm going through this quickly because I just want you to get an idea of what's out there. This is the guided wave ultrasonic technique that we strap this collar to the pipe and we shoot ultrasonic waves longitudinally in either direction of the pipe, and we can identify internal and external metal loss, whether the pipe is insulated or uninsulated, typically used on very difficult to access or costly to access piping systems, such as tank dike piping, where you have to maybe dig out the dike to get to the pipe. We can inspect it without removing the dike itself. Or soil air interfaces, it's very useful.